In last session we talked about the hashing, right? We have seen what is meant by hash table. We have seen what is hash function. Okay, we have seen what is the method of hashing actually. Okay, we have solved one problem where we have put some element into the hash table by applying a hash function, and also we have understood what is meant by collision, right? So in this session we are going to talk about collision resolution technique. Our objective is to either minimize the collision or eliminate the collision, resolve the collision. Okay, so when an element, let's understand what is collision again. When an element is already inserted into hash table, when an element is already inserted into an hash table, then another element is also inserted in that same position, or hash table means overflow condition occurs. Okay, then we have a collision and need to resolve it by applying some techniques, because when we are inserting second element at the same place, the first element will get override by the second element, right? So to resolve this, whatever techniques we are using, we are calling it as a resolution techniques, collision resolution techniques. So there are various collision resolution techniques, and their goal is to resolve or to minimize the number of collisions. Either resolve the collision or to minimize the number of collisions. That is nothing but the goal of the collision resolution techniques. So there are basically two methods of handling collisions. One is called as open hashing or separate chaining. Open hashing or separate chaining. And second is called as closed hashing or open addressing. Okay, so see here, collision resolution techniques, two techniques: open hashing, separate chaining, closed hashing or open addressing. Now open addressing has three different types: linear probing, quadratic probing and double probing. Linear probing, quadratic probing and double probing. There might be questions or problems on linear probing, quadratic probing and double probing. So let's talk about open addressing or separate chaining. We create the separate chain for every element where collision is occurring. So consider an example. The key elements are 1, 4, 9, 16, 25, 36, 9, 49, 64, 81 and 100. These are nothing but the first 10 perfect squares. Fine. Now our objective is what? In this case, hash table is implemented as an array of linked list. Every element of table is pointed to a list. The list will contain all the elements with the same index produced by the hash function. What? The list will contain all elements with the same index produced by the hash function. Now list is what? Linked list. Linked list is associated with one particular index. One index, one linked list. Second index, second linked list. Third index, third linked list. Separate linked list. Every linked list node will contain one element. One node, one element. Second node, second element. Okay. So in this technique, the array does not hold element, but it holds the address of the list that is where attached to the next lot. Each position in the array contains a collision of values of unlimited size. Now why unlimited size? Because we are using here linked list, and in linked list there is no limitation on size. So that's why every position will have a linked list of unlimited size. Any number of elements can be placed. Okay, so each position of hash table will be called as bucket, because every position is going to have many elements. So when we have large amount of elements at the single position, we call that position as bucket. Okay, so see the example now. We use linked implementation with dynamically allocated storage. Here we will chain all collisions in list attached to separate slots. This allows an unlimited number of collisions to be handled and doesn't require a priori knowledge of how many elements are contained in the collision. So this is what my table, okay, hashing table. Okay, for example, these are nothing but my all values that I have to keep in the table. Okay, and my hash function is what? H of x is equal to x mod table size. Table size is 10. Okay, so 1 mod 10 is 1, 4 mod 10 is 4, remainder will be 4, 9 mod 10 is 9. So by using that formula, we have calculated what? All hash values for all these values that we have to store, all the elements. Okay, now there is collision, 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 collision. That means in these values, these many collisions are there. So we can place first 5 values, but what will happen to the next 4 values? There is collision. So to avoid this collision, one of the technique that is used is nothing but the separate chaining. So we, in this case, key don't have to be sorted in table itself. So key don't have to be sorted in the table itself. In chaining, each position of table is associated with the linked list or chain of structures. This method is called as separate chaining, and a table of reference is called as scatter table. In this method, the table can never overflow because linked list extended up to the arrival of new keys. So when new keys comes, we create a new node and that is added into the linked list. So this is my scatter table. Okay. Now, first element, I am applying the hash function. It is giving me one value. So I am putting that one in the scatter table at the linked list of key 1. Okay. So see here. Here we have a linked list, new node is created, and now 1 is in the linked list of 1. Okay. Now next element is 4. That will be in the linked list of index 4. 9 will be in the linked list of 9. 16 will be in the linked list of 6. 25 will be in the linked list of 5. Now we have the collision for next element 6 and for 16. So here in this node we have two parts, data part and address part. So in this address part, currently all these addresses contain null value. Now whenever we got new element, so new element is 36 whose key value is 6. So in key value of 6 we already have one node. Okay, so it is having null value. Now that will be placed with the address of newly created node, and in this way we are going to create a linked list. Is this clear how the collision is resolved? Okay, next 49 collision is resolved, 64 collision is resolved, 81 collision is resolved, for 0 there is no collision. Okay, and all these last element will have null value in its pointer field, next pointer field. Is this clear? Okay, so here this table is called as scatter table. This is called as scatter table. Okay, and in this way we use a separate chaining method for collision resolution. Is this clear? Okay, now advantage and disadvantage. Hash table size is unlimited, no limitation on the hash table size. In this case you don't need to expand the table and recreate hash function, right? Collision handling is simple, just insert colliding record item into the list. Disadvantage: for short linked list this is very fast, but increasing the length of the list can significantly degrade the retrieval performance, because I want to search for example 101. So it will be in the hash key 1, it will yield the hash key 1. Okay, and it will be in the bucket of 1. So in bucket of 1 we have 11, 21, 31, 41, 51, 61, right? So after applying hash function on 101, I will get answer as 1. So I will go and search whether 1 matches with 101, no. Whether 11 matches with 101, no. So I need to check all the nodes, right? So searching performance is degraded, right? Retrieval performance is degraded. That is nothing but disadvantage of the separate chaining method. Is this clear? Okay, and then also using pointers slows the algorithm. Time required to allocate new node. So new node is created, then memory is allocated, then do the save the value of that address of that new node in the pointer field of the previous node. So that task we need to do, and that slows the algorithm. Okay, so one example which is given in the tutorial number 2, question 3. So I have given this question. Okay, so what you need to do, try to solve this and try to give the answer for this question by applying this hash function and show the separate resulting table, separate chaining table. Okay, so that will be the assignment.